Now we'll see about how to convert a given analog transfer function which is in low pass. Basically, we design an analog low pass filter either by using a Butterworth or Chebyshev configurations. Okay, so once you create an analog low pass filter using any of these configuration, how to convert that into a high pass or a band pass or a band stop filter. Okay, so how to do the transformation. Okay, so fundamentally we know how to convert a low pass to a low pass. What I mean by low pass to low pass is a normalized low pass to actual low pass. In our Butterworth design we will be doing this. Okay, to the actual low pass. For the actual low pass you will find out what is the cutoff frequency, and after finding your analog transfer function, that is your normalized transfer function h of s, which is omega c is equal to 1 radians per second. Okay, what we'll do is in that original transfer function we'll replace wherever we have s as s by omega c. This we have already seen. Okay, so you take the normalized transfer function that we have got in our Butterworth filter, okay, and replace s by omega c. Okay, this is the transformation to convert your normalized low pass filter into an actual low pass filter. Okay, but in Chebyshev filter, when you design your low pass filter itself, whatever transfer function you get, you will get a numerator and denominator. Whatever you get is directly your low pass filter for that particular specifications. Okay, so there it is not required. Okay, but for only for Butterworth design you have to convert from normalized into actual. Okay, for that alone this step is required. Okay, now for other filters, okay, suppose you want to design a low pass to high pass filter. In this case this is applicable both to Butterworth and Chebyshev. Is applicable both to Butterworth and Chebyshev. In this case a small change. Okay, so in previous case we did it as s is given by s by omega c. Here it's a small change, it should be the reverse. It should be the reverse. Why this reverse? Actually, if you see the frequency response of a low pass filter, okay, it's something like this. Okay, so here you actually find out what is omega c. So actually you will define omega p and omega s. Okay, the transition region, pass band and stop band, you find out omega c. For an high pass filter it is going to be the exact opposite of it. Your high pass filter is something looking like just a minute. So your high pass filter characteristics looks like, for low frequencies it is not going to pass, for high frequencies it is going to pass. Okay, so here also you will have, this is your pass band and this is your stop band, and here you will be having your cutoff frequency. Okay, this will be your cutoff frequency. Fine. So this why you use this simple transformation formula. Okay, for example the pass band in your low pass filter is the stop band in your high pass filter. The stop band in your low pass filter is your it will be exact opposite. Okay, so whatever be the stop band, and omega p and omega s will change here. Okay, so the formula is also changed, it is reversed. Wherever you have, after getting the low pass filter transfer function by either Butterworth or Chebyshev, in the transfer function you have to replace omega c by s, then it is converted into an high pass filter. Okay, similarly if you want to convert a low pass to band pass filter, if you want to convert a low pass to band pass filter, okay, see you are given a specifications for band pass filter, in your question it might be given. Okay, so something like this is a band pass filter, so they'll be giving you the lower cutoff, lower band frequency and upper frequency, and they'll also specify these values omega 1 and omega 2. Okay, so once these values are specified, this actually goes by 1 by square root of 1 plus lambda square, and here it is going by 1 by square root of 1 plus epsilon square. Okay, once these specifications are given, okay, what we have to do is you have to calculate two things. First you have to calculate A. So A is given by minus omega 1 square plus omega L omega U divided by omega 1 into omega U minus omega L. Okay, first you have to calculate this factor A, then you have to calculate the factor B. Factor B is given by omega 2 square minus omega L omega U by omega 2 into omega U minus omega L. Okay, once you calculate, these are the parameters available here, omega 1, omega L, omega, this will be given in the question. Okay, for this you will be finding out A and B. Once you have found A and B, you have to find something called as omega R. Omega R is nothing but minimum of modulus of A and modulus of B. Whatever be the minimum value, you have to take it as omega R. This omega R is nothing but omega C by omega P. Okay, so using this omega R, you have to design your low pass filter. Okay, so your low pass filter, I'll just put it using a different color. Okay, your low pass filter characteristic actually looks like this. Okay, so here it is omega R, and this is your passband attenuation, 1 by square root of 1 plus epsilon square, and here it is 1 by square root of 1 plus lambda square. This value is 1. Okay, so you create a using this omega R. Okay, so where you will be using this, when you are actually finding the order of the filter. Okay, you remember, you will be finding the order of the filter in either Butterworth or Chebyshev. You will be giving it as log of square root of 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1 divided by log of omega c by omega p, right? If it is Chebyshev, this log will be replaced by cos inverse. Okay, in both the formulas we'll be using this omega c by omega p. So wherever you have this omega c by omega p, you have to replace it by omega r. So this omega r we have got from this specifications. Okay, from this minimum of A and B. Okay, and you have to proceed with the calculating h of s. Once you have calculated h of s, in that, okay, instead of s you have to replace it by s square plus omega L omega U by s into omega U minus omega L. This is the last step. Okay, so what you'll do, for the given specification of the band pass filter, find A and B first, then calculate omega R. This omega R you'll be using it for calculating order. So based on the order, you will be proceeding with calculating the you'll be proceeding to calculate the transfer function. Okay, h of s. After you get h of s, substitute s by s square plus omega L omega U divided by s into omega U minus omega L. Okay, so this is how you convert your low pass filter into a band pass filter. Similarly, to convert your low pass filter into a band stop filter, okay, you want to convert your low pass filter to a band stop filter. Okay, so in band stop filter they'll be giving the specifications. So something your band pass filter response looks like this. Okay, so this will be your 1 by 1 square root of 1 plus epsilon square, and this is your stop band will be square root of 1 plus lambda square. Okay, So here you will get omega L, here you will get omega U, this point is omega 1, this point is omega 2. Okay, so from a question you will be getting these parameters. Once you get these parameters, okay, so you have to find two things. One is A is omega 1 into omega U minus omega L divided by minus omega 1 square plus omega L omega U. Similarly, B we have to find. B is omega 2 into omega U minus omega L divided by minus omega 2 square plus omega L omega U. Once you have found this A and B, okay, you have found A and B, you have to calculate omega R. Omega R is nothing but minimum of modulus of A and modulus of B. Okay, this omega R is nothing but, okay, this omega R is nothing but, so based using this omega R, you have to design your low pass filter. You have to design a low pass filter. Okay, so this is your low pass filter response. This is square root of 1 plus epsilon square, and this is 1 square root of 1 plus lambda square. Okay, so this corresponds to an pass band attenuation of 1 and stop band attenuation, this value I'm telling omega. Okay, so this is omega R. So using this specifications, you have got omega R, no? Using this omega R, you have to calculate the order of the filter, and based on that you get the transfer function. After you get the transfer function h of s, once you get the transfer function h of s, wherever you have s, replace it by s into omega u minus omega L divided by s square plus omega L into omega u. Okay, so this is how you convert your given low pass into a band stop. Okay, so these are the conversion formulas that we have to follow to convert. This is for low pass to low pass, this is for low pass to high pass, this is for low pass to band pass, and this is from low pass to band stop. Okay, so these are the formulas we have to use it to convert the given